Hello everyone, welcome to our presentation on device management essential. Let's explore the core concepts that underpin efficient device management. Let's begin by exploring the diverse landscape of devices. Devices can be broadly categorized into three main types: dedicated device, shared device, and virtual device. The first one is dedicated device. Dedicated device is dedicated or assigned to only one job at a time until that job releases them. We can give examples such as printers, tape drivers, and plotters. The second one is shared device. These devices can be allocated to several processes by interleaving their requests, such as hard disks. The last one is virtual device. These devices are a combination between dedicated and shared device. The example of this virtual device is printers that convert into shareable device. Okay, now we have explored the different types of devices. Let's shift our focus to the fundamental function of device management. Device management revolves around four key functions, which is monitoring, allocating, enforcing, and deallocating resources. Monitoring is the cornerstone of effective device management. It involves continuously observing device status and performance metrics, such as monitors, storage hardware, USB tools, and other peripheral devices. By proactively identifying potential issues and bottlenecks, monitoring enables timely intervention and optimization. Allocation is the process of assigning devices to various processes or users. This ensures that the resources are distributed efficiently and that each process gets the required devices when needed. For example, allocating a printer to a user when they send a print job. Next, enforcing involves implementing policies to ensure that devices are used correctly and according to the system rules. This includes managing permission and access controls to prevent conflicts and unauthorized usage of devices. Once a process is completed, deallocated ensure that the device is released and made available for other processes. This step is crucial for maintaining optimal device utilization and avoiding bottlenecks. Input-output or I/O request management is a critical function within an operating system. It involves several components, which is input-output traffic controller, device scheduler, and device handler. I/O traffic controller. This component manages the flow of data between the computer system and its I/O devices. It ensures that data is transferred smoothly and efficiently, preventing congestion and ensuring optimal performance. Device scheduler. The device scheduler determines the order in which I/O requests are processed. It uses various algorithms to prioritize requests, ensuring that critical tasks are handled promptly while maintaining overall system efficiently. The last one is device handler. The device handler manages the actual communication between the device. It performs the necessary operation to execute the I/O request, such as reading data from a disk or sending data to a printer. It acts as a bridge between the high-level requests from the operating system and the low-level operation of the hardware. Together, these components are ensured that I/O requests are handled efficiently and effectively, providing seamless and reliable device operation for the users.
I'm Ainun Nadhirah binti Asman. My number matric is 297348. Okay, now for my part, I would like to talk about input-output device in the cloud. So local operating system rule in accessing a remote input-output device. which is essentially the same role performed access local device, and cloud provide access to many more devices. When a user sends a command from a laptop to access a high-speed hard drive that's many miles away, the laptop's operating system will still perform many of the steps. Next is sequential access storage media. So magnetic tape is followed by the routing secondary storage in early computer system. So sequential access storage device, which can easily be visualized as an archival magnetic tape that writes and reads record in sequence from the beginning of a reel of tape to the end. So is a record stored serially, record length determined by application program, record identified by position on tape, and then record access, which is tape rotate passing under read or write head, and it's only when access requires for read or write. And then the last is time consuming process. So this is a 9-thread. 9-thread is whole a parity bit that is used for routing error checking. So 9-thread magnetic tape with 3 characters, if you can see here, 3 character records using odd parity, and a 1/2 each wide reel of tape is typically used to backup a mainframe computer that can store thousands of characters or bytes per each. So the mechanic of reading data from a magnetic tape. So the tape remains stopped until there is a request to access one or more records, and then the reel of tape starts to rotate and the tape passes under the read or write head. So means magnetic tape moves under the record write head only when there is a need to access a record. Next is inter-record gap or IRG. It has a 1/2 each gap insert between each record. So it has the same size regardless of size of record it separates. So blocking is a group records into block. Blocking is performed when the file is created and then they retrieve them when they usually unblock. So this is a formula for searching transfer rate, which is tape density multiplied transport speed. Now is an interblock gap, which is IBG. It also same 1/2 inch gap insert between each block. So it's a more efficient than individual record, and IRG it has an optimal block size, which is entire block fits in a buffer. So advantages of blocking is a fewer input-output operations are needed because a single read command can move an entire block. The physical record that includes several logical records into main memories. It's also less storage space either ways, because the size of the physical record is the size of the gate. So now is a disadvantage of blocking. Is a overhead and software routine are needed for blocking, deblocking, and record keeping. Buffer space may be waste if you need, when it's only one logical record that must read an entire block to get it. Access time can vary widely. Poor for routine secondary storage, except file with very high, which is 90 to 100% sequential activity. Access time for 2,400 foot magnetic tape with a tape transport speed of 200 IPS. So for the maximum access time is 2.5 minutes and average access 1.25 minutes, and for the last is sequential access, which is 3 milliseconds.
Hi, my name is Nur Husna and my metric number 299840. So I will present about magnetic disk storage. Okay, magnetic disk device is a computer hard device that usually feature read or write head that flow over each surface of each desk. So this device have a two type, so which is a single platter drive and dust pack drive. So single plate drive is this drive consists of a single magnetic disk on which data is stored and read by the read or write head. So for this pack drive, this drive features a stack of magnet plates known as a disk pack with a later having data stored on both sides. The plates are stacked on a central spindle and the read or write heads can move between each pair of disks to access different parts of a dust surface. So the figure below shows the typical of disk pack. Okay. Each platter have two surfaces for recording, which is top and a bottom. Each platter has two surfaces for recording data, and each surface is formatted with a specific number of concentric tracks. The tracks are numbered with a outermost circle of track 0 and the highest number track in the center. So, the picture below shows the arm. So the arm moves two read or write head between each pair of surface, one for the surface above and one for the surface below, as well as one for the uppermost and another for the lower surface. All heads move in unison, so they are posited on the same track but over their respective surface, creating a visual cylinder. Filling a desk pack surface by surface is slower than filling it up track by track. By filling tracks 0 all surface, a virtual cylinder of data is created with many cylinders on their track. Assessing a recording require known as cylinder number, surface number, and sectors number. Next, access time. Okay, depend on whether the disk has fixed or movable heads. There are three factors that can contribute to the time required to access file, which is seek time, search time, and transfer time. 6.5 is the lowest of the three factors. This is a time required to position to read or write head on the proper tracks, while for the search time, also known as a rational delay, is the time it takes to rotate the disk until the required record is moved under the read or write head. And then the transfer time is the fastest of the three. That's when the data is actually transferred from secondary storage to main memory, which is primary storage. Next, about fixed head magnetic drive. Okay, fixed-headed disk drives are fastest because each track has its own read-write head. Therefore, seek times does not play the total amount of time required to access data depend on the rational speed. Refer to as search time. There varies from device to device, but it consistent within each device. The total time also depends on the position of the recording relative to the position of the right of a read or write head. Therefore, total access time is the sum of the search time plus transfer time. So we can get the total access time. Because the disk rotates continuously, there are three basic positions of the record in related to the position of the read or write heads. So, for A, uh, show the best position show the best possible situation because the recording is the next to the read or write head when the input or output command is executed. That give a rational delay of 0. For B, um, show the average situation because the recording is directly opposite the read or write head when the input or output component is executed. And for figure C, it shows the worst situation because the recording has just rotate past the read or write head when the input or output command is executed. It gives a rational delay of t because it will take only full rotation for the record to reposition itself under the read or write head. Okay, let's move to movable head magnetic drive. Movable head disk drive add the computation of seek time to the equation. Seek time is the time required to move the arm into position over the proper tracks. So the formula is seek times plus search time plus transfer time. So we can get access time. So among the three components of access time in the equation, seek time is the longest. By blocking is a good way to minimize access time. So let's move to device handler 6 strategies. There are a 6 strategy for the input or output device. Handler is a predetermined policy that the device handler use to allocate access to the device among the many processes that may be waiting it for. So predetermined device handler determines device processing order and the goal is minimized 6 times. There are a few types. The first one is first come first serve, FCFS, shortest 6 times, SSTF, and the last one is second, scan, including look and step scan, C scan, and C look. Every scheduling algorithm should do the following: minimize arm movement, minimize mean average response time, and minimize the variance in response time. There are only a guide because 6 times is often the lowest element in the most circumstance. Access time is the fastest in the entire data required can be fully with a minimum of arm movement. In actual system, the designer must choose the strategy to make the system as fair as possible to general user pollution while using the system resource as efficiently as possible. So, first come first serve. First come first serve is a simple device coding algorithm. It is easy to program to external field to user. However, on average, it does not meet any of the three goals of SIG strategy. To illustrate, consider the single site disk with one recordable surface where the track are numbered from 0 to 49. Each take 1 ms to travel from one track to the next adjacent one. For examples, let's say the while retrieving data from text 15. The following list is required has arrived track 4, 14, 11, 35, 5, 7, and 14. Let's also assume that one has required track has been reached. The entire track is read into the main memory. So this is the pass of the read or write head look like a paragraph show. So 55 to 4 and 4 to 50 and 52, 11, 11 to 35, 35 to 7 and so on. So next is SSTF. So SSTF is mean shortest 6 time first. SSTF use the same underlying philosophy as shortest job next, where the shortest job are proceed first and longer job are made to wait. With SSTF, the requires with a track close to the one being served, that is the one with a short distance to travel is the next to be satisfied, thus tend to reduce 6 times. So the graph shows how SSTF work. Okay, 15 go to 14 and 14 to 11, 11 for 7 and so on. So let's look for scan. Scan use a directable bit to indicate whether the arm is moved to the innermost disk track or to the outer disk track. The algorithm moves to the arm methodically from the outer to the inner track, the back again, serving every request in its path. When it reaches the innermost track, it reverse direct the move and move to the outer track again, surveying every request in the past. It does not matter if there are not requests at the extreme track. The arm moves from edge to edge, which each swept anyway. So this is how scan work. So from 15 to 35 and 35 for 15 and back to 14 back and 11, 11 to 7 and 7 to 4. So there are many variations for the scan, and the most common variation of scan is look. Okay, look sometimes known as a elevator algorithm. So it which the arm does not necessarily go all the way to either edge unless there are requests there. In effort, it look ahead for a request, use a waiting queue before going to the service aid. So the next one is end-step scan. Okay, end-step scan is another version of scan that holds all new requests until the arm starts on its way back. Any requests that arrive while the arm is in motion are grouped from the up's next web, which will go all the way to the outermost track, then to be the innermost track and back, and then back again. So the next is C-scan. The arm picks up requests on its path during the innerward sweep. When the innermost track has been reached, it intermediately returns to the outermost track to start retrieve requests that arrive during in last inward sweep. With this modification, the system can provide quicker service to those requests the accumulated for the lowest number track while the arm was moved inward. The concept guiding the modification is that by the time the arm reaches the highest number track, there are a few requests immediately behind it. However, there are many requests at the end far of the disk, and these have been waiting the longest. Therefore, C-scan is designed to provide a more uniform wait time. So the last one is C-loop. C-loop is an optimization of C-scan. Just a loop is a optimize of scan. In this algorithm, the swipe inner word stop at the last high number track requires. So the arm does not move all the way to the last track unless it required to do so. In addition, the arm does not necessarily return to the lowest number track. It returns only the lowest number track that's request. So let's look the best strategy. F F FCFS is the best, the light loads because the service time is unexpectedly long under high loads. And Y for SSTF, best for moderate loads because it locates problem under heavy loads. For scans work well with a light to moderate loads, and there it eliminates the problem to identify postponement. Scan is familiar to SSTF to throughput the mean service time. For C-scans, it works well with moderate to heavy loads, and it has a very small variation in a service time. So the best secluding algorithm for a specific computing system may be a combination of more than one schema. For instance, it may be a combination of two schemes. Scan or look during light to moderate loads, and C-scan and C-looks during heavy load time. So that's all from me. Thank you.
My name is Aisyah Farha, and now I'll be taking part of rotational ordering. What it is the rotational ordering? It is to help illustrate the abstract concept of rotational ordering. It is considered a virtual cylinder with a movable read or write. Optimize search time by ordering requests one read or write has been positioned. First of all, note where the read or write head is starting from, multiple the number of track by seek time, and multiple the number of sector by the search time, and last but not least, add the data transfer time for each time. It is properly implement this algorithm, device controller must provide rotational sensing. Reduce the time waste due to rotational delay and request arrangement. So next, we go to optical disk storage. Advanced in laser technology made the use CD, DVD, and Blu-ray optical disk storage. An optical disk storage system consists of a rotating disk which is coated with a thin metal or any other material that's highly reflective. Laser beam technology is used for recording and reading data on the disk. As we can see the image over here, the CD, DVD, and Blu-ray laser. When the CD is red laser, DVD also red laser, but for Blu-ray, blue and violet laser. Okay, we move on to the types. It is CD used for audio and data storage with a capacity 700 megabyte. But for DVD, video and data with capacity 4.7 gigabyte until 17 gigabyte. For the Blu-ray disc, high-definition video and large data storage with a capacity 25 GB and until 128 GB. How does it work? Reading data by a laser beam in the optical drive, read and the disc by shining surface, and it is writing data recordable and writable disc with a laser change the physical properties of the disc surface to encode data. Okay, how about the advantage and disadvantage? Now we look at it. For advantage, durability, resistant to environmental factors like magnetic field and water. For portability, easy to transport and store it. Longevity, properly stored disk can last many years. For the disadvantage, storage capacity generally lower compared to the modern storage solution SSD and HDD. How about the speed? The speed is lower, read and write speed compared to SSD and even some HDD. Physical damage is susceptible to scratch and physical damage, which can lead to the data loss. If the CD or DVD have a scratch on the surface, it is considered to data loss. Okay, this is damage on the surface. So we move on to this, as we can see here. Okay, so what is solid state drives? SSD. It is provide persistent data storage using no moving part. It is sometimes called semiconductor storage device or solid state device. SSD is often used as secondary storage to provide relative fast, persistent direct attached storage in a computer. It is fast, but a little bit pricey. And as we can see here, data transfer rates often decline over time. For example, a new SSD is much faster than a hard drive, but it starts slowing down after being for only a few weeks and continues to degrade over time. So this happen because data on the SSD is frequently moved to different locations to ensure even wear a process called wear leveling, which gradually reduce the SSD performance. So the longer we use the SSD, the performance will reduce. So it's not compatible. So as we can see here, perbezaan hard disk drive and solid state drive. Access time, hard disk drive is lower but SSD faster. Power consumption is higher but SSD is lower. Weight heavier but solid state drive is lighter. Noise production, hard HDD is louder but SSD silence. Contain moving part, yes, but not for SSD. Cause as we can hear earlier, SSD is more pricey than HDD. Very high capacity. HDD is yes, but not for SSD. Lifetime writes and rewrites longer, and solid state is shorter. Okay, thank you.